Hi guys, welcome to my YouTube channel. I am Sabina Aydnova. Today I am going to show you explain Cauchy integral formula. This Cauchy integral formula, I'm going to solve this as the integral as a sum of two integrals. First, let's write the Cauchy integral formulas. Analytic function f of z0 is equal to 1 over 2 pi I times integral f of z over z minus z0 dz. Integral f of z over z minus z0 dz is equal to 2 pi I times f of z0. And another function f of z0 can have complex derivatives of all orders. And complex derivatives of all orders is equal to m factorial over 2 pi I times integral f of z over z minus z0 to the power of m plus 1 dz. And this part of it will be equal to f of z over z minus z0 to the power of m plus 1 dz is equal to 2 pi I over m factorial times derivative of f of z0. Firstly, let's look at the disk of this Cauchy integral formula. It is less than 2, and let's look at the singularity points of the Cauchy integral formula. In order to find the singularity points of the Cauchy integral formula, let the denominator of the integral be equal to 0. In this case, it has two singularity points. One of them is 0 and one of them is equal to 1. And let's check that if the singularity points belongs to the disk or not. You know, it is center at 0 and radius is equal to 2. 0 belongs to this disk and 1 also belongs to disk. 0 is less than 2 and also 1 minus 0 is less than 2. Then both of these singularity points satisfy the Cauchy integral formula and belongs to this disk. Okay, let's solve this Cauchy integral formula as the sum of two integrals. Those integrals will be equal to dz plus and sum of them is equal to given Cauchy integral formula. Let's solve each of them separately. In this case, this is in the form of the complex derivative form of Cauchy integral formula, and in this case f of z is equal to e to the power of z over z minus 1 and z minus z0 to the power of m plus 1 is equal to z squared. Let's find m and find the complex derivative of it. Z minus z0 to the power of m plus 1 is equal to z squared. It means that z minus z0 is equal to 0 and m plus 1 is equal to 2. If m plus 1 is equal to 2, then it means that m is equal to 1 and z0 is equal to 0. Then 2 pi I over m factorial found that m is equal to 1, m factorial times first derivative of f of z0. Let's find first derivative of it. F of z is equal to e to the power of z over z minus 1, and first derivative of f of z will be equal to and if we take into account that if we find the first derivative of f of z0 and z0 is equal to 0, then let's write 0 instead of z. E to the power of 0 times 0 minus 1 minus e to the power of 0 over 0 minus 1 squared will be equal to 1 times negative 1 minus 1 over 1. It is equal to negative 2. Negative 2, yes. So f of z0, derivative of f of z0, first derivative is equal to negative 2. Then it is equal to negative 4 pi I. It means that we found the first Cauchy integral formula. It is equal to negative 4 pi I. And let's look at the second part of it. Second part of the Cauchy integral formula is equal to f of z over z minus z0 dz, and it is equal to 2 pi I times f of z0. In this case, z0 is equal to 1 because z minus 1 is equal to z minus z0, and e to the power of z over z squared is equal to f of z. And we just have to find f of z0, and f of z0 is equal to f of 1 because z0 is equal to 1. Then let's write 1 instead of z. Let's substitute 1. E to the power of 1 over 1 squared is equal to e. Then the Cauchy integral formula will be equal to 2 pi I times e because f of z0 is equal to e. Then the second part of the Cauchy integral formula is equal to 2 pi I times e. Then the total answer is negative 4 pi I plus 2 pi I e, and let's factorize it. It is equal to 2 pi I times e minus 2. Solution of this Cauchy integral formula is solved like this. I hope that you understood. If you like this video, please hit the like button. I make such this kind of mathematical videos on my YouTube channel. You can check them out. Thank you for watching this video till the end. And please subscribe to my YouTube channel, like my videos, and leave a comment to support me. Goodbye. See you soon on other videos. Goodbye.